Welcome everyone. In this lesson, we are going to explore Archimedes' principle, a very important concept in fluid mechanics that helps us understand why objects float or partially float. By the end of this lesson, you will be able to explain floating objects using buoyant force, density, and displaced fluid. Let's start with something simple. Imagine pushing a ball underwater. You feel a force pushing back upward, right? When you release it, the ball immediately pops back to the surface. This upward push comes from the water itself. Why does this happen? It happens because the pressure at the bottom of the ball is higher than the pressure at the top, creating a net upward force. This upward force is called buoyant force. Buoyant force is the force exerted by a fluid on an object that is partially or fully immersed. While gravity pulls the object downward through its weight, buoyant force pushes it upward. Whether an object floats or sinks depends on which force is stronger. For a floating object, something very important happens. The buoyant force equals the weight of the object. This also means the weight of the object equals the weight of the fluid displaced. When the object floats in water, the density of the object is less than the density of the fluid. Besides, the volume of displaced fluid is equal to the volume of immersed object. We can use this basic formula for the calculation. Now let's apply the concept to a real example. We have a wooden block floating in water. Part of the block is above the water and part is submerged. From this situation, we are going to find the buoyant force, the weight of the block, the density of the block. First, we calculate the volume of the object and the volume of the immersed part of the block. Next, we apply Archimedes' principle, which states that the buoyant force is equal to the weight of the object and also equal to the weight of the displaced water. By substituting the known values into the equation, we obtain the following results. The buoyant force is 43.2 newtons, and the weight of the block is also 43.2 newtons. Since the block is floating, these two forces are equal and balanced. Finally, we calculate the density of the block. The result shows that the density of the block is lower than the density of water, which explains why the block floats. Archimedes' principle is not just theory. It is used in real construction projects. In flood-prone areas, buildings are designed with buoyant foundations. When floodwater rises, the structure displaces water and floats safely instead of collapsing. This reduces damage and saves lives. Floating bridges use hollow pontoons that trap air. These pontoons displace a large volume of water, creating enough buoyant force to support the bridge structure, vehicles, and people. Engineers carefully calculate buoyant force to ensure safety under moving loads. Even though ships are made of metal, they float because their shape allows them to displace a large volume of water. The plimsoll line on the ship shows the maximum safe load level. If the ship sinks below this line, it becomes dangerous. This is a direct application of Archimedes' principle to ensure the safety. To summarize, an object floats when the buoyant force equals its weight. The object's average density is lower than the fluid. Enough fluid is displaced to support the object. Archimedes' principle is essential in construction, marine engineering, and safety design. Without it, ships wouldn't sail, bridges wouldn't float, and flood-resistant buildings wouldn't exist.